Welcome back to part 2 of our series on how to use a tree diagram to find the probability. In this lesson, we'll be looking at a more complicated question, and as we learned in the introduction, we can represent an experiment that happens in stages with a tree whose branches represent the outcomes of the experiment. We calculate the probability of any outcome by multiplying the probabilities found along the branches representing that outcome. With that being said, assume that we are working for a company that has a mandatory drug testing policy. It is estimated that 2% of the employees use a certain drug, and the company is giving a test that is 99% accurate in identifying users of this drug. What is the probability that if an employee is identified by this test as a drug user, the person is in fact not a drug user? Essentially a false positive. To answer this question effectively, let's set the variable d to represent the event that the person is a drug user, and the variable t to be the event that the person tests positive for the drug. Again, what we want to know is what is the probability that the person does not use the drug given that he has already tested positive. Since d represents that the person is a drug user, let's use the symbol d prime to represent that he is not a drug user. And in probability, we call this the complement of d. So this is the person is a drug user, this is a person is not a drug user. So to build our tree, we can have two branches where the first branch tells us that the person is a drug user, and the second branch, the person is not. In the question again, it says that 2% of the employees use a certain drug. So there is a 2% chance that it goes in this branch. I'll represent that as 0.02, and a 98% chance that it goes to this branch. Essentially what we are looking for is the probability of d prime under the condition that they have been tested positive. And that's what we're looking for. So to continue building our tree, now we have two branches for each of these nodes. This branch will be that the person tests positive. There's a 99% chance that it will be accurate according to the test. And for this branch, we'll write down t prime, which is the opposite of the following. T prime being that the person doesn't test positive for the drug. And that chance is 0.01. That's how confident the test makers are with their test. The same two events can be written here. The probability of this one is 0.01, and the probability of that is 0.99. Now to find the conditional probability for what I wrote earlier, we need to remember the following formula. This formula is only used for when two events are dependent. Here it is again related to the complement of d and t. This can be found easily by multiplying this number with that number. So for the top, the numerator, we have 0.98 times 0.01. And at the bottom, the probability of t occurring, that can happen by multiplying 0.02 and this route down this branch and up to capital T. Therefore, 0.02 times 0.99 plus 0.98 times 0.01. Finding out what that is goes into there. Now let's use our calculator. It was 0.98 times 0.01. That results into the following number divided by, at the bottom, 0.02 times 0.99 plus 0.98 times 0.01. We end up with 0.33. 0.33 is the probability. Now to interpret this result, that's the probability that an innocent person will test positive for the drug. And so there you have it, Another example on how we can use a tree diagram to help us find the probability.